Good morning, good afternoon, good evening, everyone. My name is Cameron Covington. We'll get started here in just a couple minutes. Just give everyone a chance to join. Thanks for joining, everyone. We'll get started here in just a minute. Good morning, good afternoon, good evening, everyone. My name is Cameron Covington. I am the Manager of Services and Product Development at Whetstone Technologies. I will be delivering today's presentation along with one of our account executives, Amanda Galini. So we'll be discussing data hiding, understanding and emerging and covert threats. So we'll be discussing areas of steganography as well as malware detection, the problems that those can pose for an organization, and then how a forensic solution such as the ones that are offered by Whetstone Technologies can solve those issues. So with that said, let's go ahead and get started. So first, I'd like to talk about an overview of steganography. So there are several different types of steganography. We'll talk about those. We'll talk about some of the algorithms that are used to hide data, and then how to actually detect that hidden data. But first, I think it's important, because not everyone is familiar, to actually define, what steganography is. So steganography at a high level is the concept of embedding data within another form of media, for example, in the digital world. So when we think about steganography and data hiding in general, we're thinking about embedding some media, whether that is text, whether that might be another image itself, or anything like that within the contents of another form of media, which would be considered the carrier file. And we'll get into that here in a little bit. But then the idea is to be able to pass those messages within that carrier file totally undetected to any unsuspecting viewer of that image. So the idea is to open the image, you not be able to tell that there's any embedded content within it. But in fact, there is a secret message that is contained within it. And those that know, to look for that content, they would be able to extract that out and then pass, for example, messages back and forth, or extract out the hidden data. So when we talk about, steganography, that's what we're talking about at a high level. There are multiple different types of steganography. So malware-based steganography, where we're actually seeing malware being embedded in some other type of file in order to deliver a malware payload to infect a victim and execute some type of malware on the victim's system. There's also network-based steganography, which we'll get into in a little bit, where we actually see content embedded within IP packets themselves, and how messages can be passed back and forth within an IP packet. And then media-based, which is what I just talked about previously, of inserting media, whether that is any form of content within another media file. Then there are different algorithms that are able to actually facilitate this data hiding. So data insertion, that would be one of the most trivial methods used to hide data, in which you would actually just include content in, for example, the header or after the end of image or end of file marker of a file, and you would be able to detect that within something like a hex editor very easily. But then there are more sophisticated algorithms that can be used to actually facilitate this as well. One of those being least significant bit, or LSB for short, in which the least significant bit of these values within the media can be modified to embed data within those, so that it is totally invisible to any unsuspecting user. So we'll actually show a few demonstrations of this as well. In addition to DCT, or discrete cosine transform, in which we're modifying the DCT coefficients of a file to be able to actually embed data like that as well. And then finally, there's something called JP hide and seek. That is a tool actually that is used to embed content within something like a JPEG file. So we'll also be talking today about malware, and specifically malware and even potentially unwanted programs, or PUPs, that we are detecting by gargoyle investigators. So when we're talking about our products today, I do want to mention right out that when we're discussing things like Gargoyle as well as Stego Hunt, we're not looking to actually stop any type of threat. For Gargoyle and malware detection, it's not actually an antivirus program. It's a digital forensics tool that is used to report on the presence of something like ransomware, spyware, remote access programs, crypto mining, or cryptojacking. The program is not designed to stop that. There are other antivirus vendors who are, in that space. There's hot competition there. The niche that Gargoyle Investigator is filling is actually providing a digital forensic solution to report on that, to then be used in a digital forensics case later. And these are just some of the examples of the actual categories of programs and files that Gargoyle Investigator will detect and be able to report on. Amanda's going to give a more comprehensive overview of both of the products, Gargoyle MP, Stego Hunt MP, as well as Stego Command here in a little bit when we talk specifically products. But I did want to go ahead and right out of the gate describe some of the malware and potentially unwanted programs that I'll be talking about throughout the presentation, just so that you would have an idea of what we're talking about here. So some common terms, pivoting back to steganography. I mentioned some of these before, but the first one is a carrier file. So as I go through, I think it's important to make sure that everyone is familiar with these terms. And these are pretty industry specific, but common in the area of steganography. So a carrier file could be defined as an innocent looking file used to conceal hidden data. So as I mentioned before, that would be the file that is used to hide the data and be what the user would see, if they open this file. So it could be, just a normal JPEG, an unsuspecting user opens it, they just see a normal file. It'll open in their system just fine in their file explorer, and they won't have any idea that there's any hidden data embedded within it. Now, that hidden data is called the payload. So the payload can be defined as any of the content that is hidden that is stored within a carrier file. Now, we also have a term steganalysis, or you could think of that as steganography analysis, which would just be the process of analyzing hidden data. So included in the Whetstone portfolio specific to steganography, there are detection tools like StegoHunt and StegoCommand, and then there are also more analysis tools that are designed to let you really dig deep into the analysis of the media, be able to look at things like a hex dump of a file, or look at a histogram, or view a file, an image with different color filters enabled, to be able to try to really hone in on the embedded data that might be present within that file after detecting it. LSB, we talked about previously, least significant bit, and then DCT, or discrete cosine transform. So all of these types of algorithms that would be used that I'll discuss today to facilitate data hiding are detected by StegoHunt and StegoCommand. So all of these will be supported for hidden data to be detected in a StegoHunt or StegoCommand scan. So when we talk about steganography, it's important to realize that there aren't just illegitimate uses for steganography. There are plenty of uses that are considered legitimate. And so over here, I've got several. So the first one, digital watermarking. So that, of course, can be used to show authenticity of a document. Songs and videos are often copyrighted using imperceptible sound or video that is used for copyright violation detection. So for example, if content is posted online to something like YouTube, that imperceptible sound or video, of course, if it's a video file, can be detected by YouTube's algorithms, and that is what's used to actually flag for copyrighted material that might be present in someone else's content. You can also hide a decryption key for file decryption. This is actually a pretty common use case where you have an encrypted file. That encrypted file can be distributed, for example, from one user of an application to another, and that file can actually have the decryption key embedded directly within it. Of course, the user, as they're viewing the encrypted file, would have no way of knowing where the decryption key is because it's embedded within the file. So for example, everything could be passed within an image file. And then finally, printer and scanner dot pattern identification. So this is one that is actually pretty common, and one that sort of gets people in trouble sometimes, where an invisible to the human eye dot pattern is printed on paper that is able to identify what printer printed a document. And so you can look at this invisible dot pattern and be able to tie what was printed on this physical piece of paper back to an individual printer at a specific location. So those are some legitimate uses for the concept of data hiding and embedding data. There are, of course, many illegitimate uses associated with it. Of course, child pornography, child sexual abuse material is a very common one that is seen with the use of steganography. So actually embedding this type of material within other benign files in order to try to prevent detection should there be a digital forensic investigation of the system. Propaganda distribution. So Al-Qaeda actually embedded more than 100 planning documents in it was actually a pornography film. But we see that this type of content and a lot of data, as I'll show here in a little bit, can actually be embedded within these files. And so something as critical as excuse me, something as malicious as Al-Qaeda documents can be presented, and passed within propaganda type material. malicious content and network traffic. So as I mentioned before, network traffic is on the rise. It can be used to either hide data in non-malicious IP traffic or IP packets, or it can be used to mask traffic by using non-default ports. And so, network steganography, as I mentioned, is definitely on the rise, and we're seeing that more often. Malicious programs have been discovered that are embedded within image files. Zeus VM Olympic Destroyer, which actually affected the Olympics a few years ago, in which content was hidden in a Word document in an image. And I'll actually dive more into that specific example here in a few minutes. But the illegitimate content, the actual malicious content, was stored within an image that was stored within a Word document that was attached in an email. And that was the method of delivery for that malware attack that took down the Olympics for an extended period of time. And then finally, sharing corporate secrets using encoded messages. So another very common use case for steganography, and specifically steganography detection, is in the concept of DLP, or data loss prevention, in which the content going outside of a corporate network is analyzed in order to determine whether or not any embedded data could be present to detect any type of data exfiltration of corporate secrets. So we just talked about steganography related use cases that would be detected by something like Stego Hunt MP or Stego Command by Whetstone Technologies. I did want to go through really quickly some modern uses of programs detected by Gargoyle Investigator, so you can see some of the differences in the two products and how they might fit into your workflow. So some legitimate programs and legitimate use cases over here on the left. So keyloggers, of course, can be used for corporate device monitoring, but they, of course, have an illegitimate use case as well. And so it's important to be able to differentiate, if your use case requires a detection of something like that, of whether or not it would be considered a legitimate use case for something like a keylogger, or an illegitimate use case in which it would be stored on a system and the user is unaware of such logging taking place. Encryption, of course, that's a big one that can have both legitimate and illegitimate uses. Encryption for the purposes of data protection in a corporate environment, for example, or even a personal environment, but also encryption in just the basic concept of attempting to hide material, whether it's child exploitation material or anything like that, from any type of investigation that may take place. Crypto mining is another one that is certainly on the rise, in which there is legitimate mining for cryptocurrency, but that is something that is able to be detected on Gargoyle Investigator. And again, that could be used for a legitimate use case, or over here on the right-hand side, also an illegitimate use case if something like cryptojacking is used, in which a system is being used unknowingly by the user to actually mine for cryptocurrency without their knowledge or consent. Of course, there are peer-to-peer applications as well, which many of us use on a daily basis. For example, OneDrive, Dropbox, Google Drive, things like that, which absolutely have a legitimate use case of being able to facilitate data storage within the cloud and be able to share that among colleagues. But there are also illegitimate use cases for this as well, which would be used to pass those materials, whether it's stegware or anything like that, back and forth. And then finally, remote access, the same type of thing, something like TeamViewer or remote administration tool. And those all have legitimate use cases, but those can also have illegitimate use cases that could be used by a malicious actor. And so all of these have value to be detected within a Gargoyle Investigator case. Finally, some illegitimate use cases I'll go through really quickly. Ransomware, of course, that is in the news seemingly every day at this point. There's always a new ransomware attack. Whetstone does maintain signatures for the most recent and most critical ransomware attacks. And those are able to be detected as well. So the presence of ransomware can be identified on a system, but again, that is not remediated by this particular use case. Of course, Trojans, again, whether that's malware embedded in content like a malicious Word document, for example, or things like that. We already discussed cryptojacking. Piracy, so in the same context as even peer-to-peer, of course, pirated content, stealing resources from the copyright holder and then distributing that out. And then finally, rootkit. So of course, having root access to a system without the user having any knowledge of that, that is actually something that can be detected, those rootkit programs, by Gargoyle Investigator as well. So stegware, as I mentioned before, we're talking about, and specifically in the context of stegware, tools that are used to actually hide a payload within a carrier file. So these programs facilitate the data hiding. Now, you can actually see, of course, malicious data, whether it's programs, actual applications, executables, text, image, video, audio can be embedded within files. There are many different programs that are used to facilitate this data embedding. There are many on the market. There are many even on GitHub, not full commercial tools that can be used, and new ones are coming up every day. And it's very hard to actually keep track of what is on the market and what is a threat to your organization. Of course, this can even be used to send botnets, so command and control commands, back to have malware embedded within an image and then send that out as part of a malware campaign. And so really the possibilities are endless in terms of what can be embedded within these files. And then unfortunately, that also means that the possibilities are endless in terms of the risks that can be associated with that. It, as I mentioned, it facilitates exfiltration of sensitive data in seemingly benign files. So, an example of that would be the corporate DLP use case that I mentioned previously. And then it can pass invisible information and photos uploaded to social networks. And that's actually one that is on the rise as well, where something like Twitter has no validation for the types of content. There are no checks to determine whether or not there is embedded data within an image that is posted to something like Twitter. And that can pose a significant challenge, of course, for something, a platform as large as something like Twitter, because the entire idea is to distribute media, and steg monitoring on such a large scale is a very hard problem to solve. So even the largest corporations like Twitter, Facebook, things like that, still see this as a threat, and of course it's something to pay attention to. So as I mentioned, some malware campaigns that have utilized steganography, there are quite a few. So of course, Olympic Destroyer was one of the last big ones that really got a lot of news attention back a few years ago. It was interesting because it had malware hidden inside an image that was embedded within a Word document, as I mentioned before. And it deleted shadow copies, event logs, and it tried to basically destroy systems. Its purpose was not intended to actually steal data, which probably could have been accomplished as well with this particular technique. But its sole intention was to just destroy the systems associated with the Olympics a few years ago and be able to actually, bring down the Olympics while the world is watching. So it originated from a spoof National Counterterrorism Center email address. The PowerShell script begins execution when a user clicks enable editing in a Word document. So of course, as many users do, they open the attachment in the email. Word prompts them to enable editing to be able to display all the content. The user is happy to do so, and then the script is hidden inside the image that's in the Word document. And then using invoke PS image, which is an open source data hiding tool, that script is then executed by the local system, and Olympic Destroyer begins destroying, as its name suggests. Zeus VM is another one that was and really continues to be pretty popular. So that's a Trojan that uses a man-in-the-middle attack to intercept banking information. That initiated wire transfers using authenticated sessions because the credentials were, of course, stolen. And then it altered the account balance of the customer. So when the customer saw their information, everything looked normal, but that was malware that was contained within a JPEG image. Another example very quickly, from January 2017 to August 2017, IBM noticed a 600% increase in crypto mining programs embedded in other files. That, of course, has continued to rise as time has progressed, especially, we really saw an increase in overall malware trends, of course, but even in the crypto mining space over the COVID-19 pandemic when everyone was on lockdown. So these programs were embedded in images, and modified versions of legitimate crypto mining tools actually were used to facilitate crypto mining. And you can see the crypto mining tool there, Minored. And then finally, phishing emails with embedded link redirects. So you could attach a PDF from an address, whether it's a spoofed email address, as in the Olympic Destroyer example, or really any others, to have a user open a PDF, for example, and it contains a link that appears to go to a legitimate site, but then the user clicks the link and is redirected to a malicious site that downloads, zip file, for example. The zip has PNG with a malicious program detected, and then that code is automatically executed as the PNG is opened on the system, all without the user having any knowledge of this whatsoever. So as I mentioned, I did want to discuss a few specific examples and dive a little bit deeper here. So this is Olympic Destroyer, and you can actually see here some of the information associated with it. So here's the Word document. The Word document actually has an image of what appears to be text. And so the user can't actually tell without clicking on it, of course, that there's any image content even within the Word document, but it is there, and then it is executed, and you can see the PowerShell commands that are used right here. And of course, PowerShell is another one of those threats that is very hard to detect at scale efficiently as it's being executed, because if an organization has a need to have PowerShell enabled, for example, then it's much harder to detect malicious PowerShell versus non-malicious PowerShell, especially at scale and in real time. Zeus VM, so this was actually the JPEG that was used to facilitate the Zeus VM banking Trojan. So as soon as this file was opened on a local system, it would actually begin execution. It's only an 800 by 600 JPEG, so it's relatively small. It's of course rather grainy. Some of that can be attributed to the malicious content that is embedded within it, because sometimes there is some distortion that is present depending on the level of content that is embedded within that file. And then here's an example of steganography in network protocols. I won't dive too deeply into this, but this was first documented in 2003, and it hides information in standard network transmissions. So the headers of a network packet are prime targets for data insertion, because there are fields here that don't have really any type of error checking. So for example, options and padding, this can be 0 to all the way up to 44 bytes. So malicious content can be embedded with something like that. There are other areas here as well that could be either manipulated or totally changed and have embedded content included with it to pass in multiple IP headers in succession. So it of course hides information in standard network transmissions, and then interpacket gaps, so the time between network packets and order of header elements are prime targets for something like this type of attack. So there are some recent cases of network steganography that we've seen in the wild. Transsteg, which is short for transcoding steganography, utilizes the network protocols VoIP uses, so voice over IP, to pass hidden information across the network. And so that's very difficult to actually detect, but it's because, of course, that's something that isn't really even monitored all that closely on a typical network, because IP telephony data, of course, in a traditional sense, doesn't really have that much of a risk to an organization, but it can perform lossy compression of IP telephony data and then use those voice transmissions and compress those voice transmissions down to make room for hidden data. And so you can see over here, the next example, Morto Trojan, which uses DNS requests to look for non-existent domain names. So the DNS server is queried by the Seek2 server, and then the response back from the server contains the commands that are inside the response. But typical network monitoring solutions wouldn't be able to detect something like this because of the encoding that is present there. Moscow used steganography to hide images in innocent looking or hide messages in innocent looking images to communicate with Russian spies in America. So that was something that was in the news fairly recently. And of course, a very dangerous use case for something like having Russian spies that are on foreign soil and having those communications back and forth where, again, in traditional monitoring situations, those messages would not be intercepted because the extraction of the hidden data wouldn't be present. I mentioned a little bit earlier, Osama bin Laden may have been using steganography to freely distribute hidden messages in propaganda videos. So, hundreds of documents in that example that I mentioned previously were stored within video files. Operation Twins, so that was a large campaign to unfortunately distribute a lot of child pornography and child exploitation material back in 2002. That was one that was in the news very highly. And then finally, exfiltration of data from the US Department of Justice, in which sensitive personal data was stolen. And then, of course, US information has been exfiltrated to Russian spies using steganography as well. So a couple more examples really to just drive this point home, and then I'll turn it over to Amanda to discuss, how we can actually detect these types of threats using our products. This example looks like, if you might recall, this looks a lot like Windows XP, right? The wallpaper for Windows XP. Normal looking image, you can't tell anything is odd about this image. Everything looks normal. It's not a very high resolution, especially if you look at the edge of the hill here compared to the skyline. There is a little bit of distortion, but nothing that would necessarily cause alarm. But within this single image, there are 10,004,560 words, or one example that everyone likes to use in the steganography space, the entire collection of Shakespeare. So all of Shakespeare's works can be hidden within a 1920 by 1080 image. A standard HD image can be used to contain all of Shakespeare's works in a single image. And so hopefully that gives you an idea of how much data can be hidden in just a single JPEG and the risk that could be associated with it. So if you're not familiar, a typical JPEG can, or a 1920 by 1080 JPEG can store 1.48 megabytes. And then the entire works of Shakespeare contains 37 plays, 154 sonnets, 124,788 lines of text, and then finally 10,004,560 individual words. So obviously a lot of content that is actually hidden within this JPEG image right here. Another one, this is a kind of a cool example. So this is the payload that is embedded within this cover image. So you can't actually tell, of course, anything, which is obviously the objective in order to facilitate data hiding. But this map image is embedded within this cover image. So the map of the Burlington International Airport right here is a GIF. It is 11,067 bytes, and it was embedded in this carrier file using the tool GIF it up, which uses LSB steganography. So the original carrier file is 632,000 bytes. The payload, as I mentioned, is 11,000 bytes. And then the file that is used, or the stagged file with the cover image containing the payload, is 677,000 bytes. So it's 33,000 bytes less than a simple carrier plus payload addition in terms of the embedded content. And so you'll see that a lot where some compression is used, for example, to try to maximize the amount of data that can be stored within an individual cover image. Data insertion. This is one, as I mentioned previously, I just wanted to show you a quick example of this. The most trivial form of data embedding in which content can be stored within the header of an image, for example. So you've got the standard JFIF here in a JPEG, and then just data insertion being written. And then that, of course, is still rendered by the File Explorer with no problem. And the user would be able to open this image and not have any idea that there was any data embedded there. And similarly, data can be appended to a file after the end of file or the end of image marker. It's called data appending, where after you have the end of the file data, most of the files would have no problem at all with you adding something like this as a secret message. The File Explorer is just looking for the start of the image data to the end of the image data, and it doesn't really pay any attention to anything after that. And so that is totally allowed in terms of what the operating system will render. So as I mentioned, it's one of the easiest data hiding methods, but this, of course, can be easily detected using a hex viewer such as WinHex. The LSB algorithm involves manipulating RGB values in multimedia files. So the common target is the last bit in an 8-bit RGB value. So if you're not familiar, of course, RGB, you've got red, green, blue, and we're specifically looking at the last bit in these RGB values. And so this exploits really the human's inability to detect subtle differences in color. So if we look at these two colors here, most people would actually say, of course, this is the same color. This visually looks exactly the same, but there's an imperceptible color difference. And we've actually changed 3 least significant bits. So the left color is 25500, and then the right color, of course, modifying the least significant bit of each of these RGB values, we have 25411. And so again, visually, there isn't a difference in the two that a user would be able to see and the traditional human would be able to see, but these do present anomalies in the LSB values that are able to be detected using Whetstone Technologies tools that we have in place. That was just one LSB. 2 LSBs can also be used. So a couple quick examples here. A Twitter profile picture can hold 117K, just this standard image here. It can hold that much data. If we're looking at something larger, like a NASA high-res image of Pluto, for example, that's 8,000 by 8,000, that can hold all the way up to almost 46 megabytes of data, totally invisible to the user. Talked about the desktop background photo at 1920 by 1080 can hold almost 1.5 megs. And then finally, a very large image like a panorama of the Milky Way could have something like 78 megabytes contained within it. So there is the risk of having a significant amount of data that is stored within these. So let's actually go to, Amanda, I'm going to turn it back over to you to discuss some of the products that Whetstone has and how these types of threats can be detected by your organization, whether it's in the context of a digital forensics investigation or something like a post-mortem investigation. So Amanda, over to you.
Thank you, Cameron. Hi, everyone. My name is Amanda Galini. I am an account executive here at Whetstone Technologies. And as Cameron said, I'm just going to take a few moments here and give you a brief overview of what we do and the products that we currently offer before Cameron shows you a demonstration of the products in use. So, our research and development division of Whetstone Technologies, known as Whetstone Labs, performs malware research and develops a suite of advanced digital forensics and incident response tools, supporting a wide range of investigative needs. That means whether responding to an incident, performing security audits, exposing steganography usage, or collecting evidence from live systems, our solutions provide our customers with tools that are needed to better understand a cyber threat and to assist them in profiling the intent, sophistication, and capabilities and communications of an attacker and or potential suspect. Whetstone Labs maintains a repository of malware. This is segmented into 25 categories, included anti-forensics, ransomware, spyware, cryptojacking, and fraud tools, just to name a few here. The data sets in this repository are utilized by the Gargoyle family of malware discovery tools. And the steganography and encryption data sets are provided to our Stego Command and Stego Hunt users to detect and identify known data hiding programs. Excuse me. The first product that I'll showcase here is Gargoyle. Gargoyle MP is a multi-platform tool used in forensic investigations, incident response, and other forensic activities to detect malware and potentially unwanted programs. Gargoyle MP was designed for forensic laboratories, law enforcement, field investigators, advanced private investigators, and enterprise security personnel. It is important to note, as Cameron mentioned before, that Gargoyle MP is not an antivirus tool. It detects the presence of malware and potentially malicious files using signature identification. These signatures are provided by Whetstone to Gargoyle MP users monthly in our dataset updates. These are provided in our customer support portal. Users have the ability to generate custom MD5 data sets as well. Gargoyle MP can be used with third-party forensic toolkits. It supports evidence file ingestion from a variety of forensic toolkit applications. So this includes Paraben, Access Data, EnCase, and Autopsy, if you're familiar with those. This feature will save the investigator time, and it allows for quicker access to files detected on a suspect's drive. Moving over to Stego Hunt. Stego Hunt MP is our steganography program detection application and steganalysis suite. Stego Hunt effectively detects the presence of both steganography and data hiding programs, as well as carrier files. This application was designed to give the user several options regarding the configuration of a SAN. So examples, the user has the ability to select up to 4 drive letters or individual directories at a time to be scanned. Users may select a hash file to scan from a previously run scan of Stego Hunt. And specified directories may also be excluded from a scan. This will streamline your investigation. We also provide a factory whitelist of core system and common application files that are known good. Users have the ability to create their own custom whitelist as well. This could be useful, for example, whitelisting all files in a golden image. And of course, thirdly here, we have Stego Command. Stego Command provides a command line steganography detection for a variety of file types. It is customizable to your organizational needs. So as you can see here, there's a list of currently supported file types, but research and development, as well as custom file types, are available. Stego Command provides detailed reporting on detected data hiding methods that are used in the files, as well as payload carving of hidden data. This is done so that carved data can be further examined. Stego Command also provides detection of steganography creation programs. It does this by using Whetstone Technologies dataset files, which contain thousands of signatures of steganography and encryption programs, as well as artifacts of these programs. Stego Command, as well as Stego Hunt and Gargoyle MP, are very intuitive, and we find that it does not require a large amount of technical knowledge to use them. And as I had mentioned before, Cameron is going to go ahead and do a brief demonstration of these products for you so you can see them in use.
Thanks, Amanda.
Thanks, Cameron.
All right. Thank you. All right, so just very quickly, we'll have a demo of each, both Gargoyle and Stego Hunt, and then I'll turn it over and open the floor for questions. So if you do have any questions, please use the Q&A feature of the webinar, and we will do our best to address those either in the Q&A forum specifically or live here and answer any questions that you may have. So if we look at this, let me get the video going. All right, so the first demonstration is the Stego Hunt MP user interface. And so you can see here it's very straightforward, as Amanda mentioned. You've got drives and directories that you can scan, so you can have multiple targets, whether those are individual directories on a system or even a mounted image file. As long as the system that is running Stego Hunt or Gargoyle, for that matter, is able to traverse the file system of the mounted image, then the tool will be able to scan that. So the only requirement is just that the image file will be mounted if it's not scanning the live local system. There are some scan options available here. For example, carving out images from multimedia files. So Stego Hunt has the ability to carve images from things like Word documents and PowerPoint presentations, for example, and then extract and process those image files individually and separate from the document that contained it. Network files can be scanned. So for example, if you're scanning a live system, it can pull down files that would be stored in mapped network locations such as OneDrive, and then creating a case, as Amanda mentioned previously, can be used to capture all of the image files that would be detected in a Stego Hunt MP scan. So anything that determines or that is classified as a suspicious or as a warning hit for the possibility of data embedded within those files, all of that can be processed and stored in a single data repository location so that you can access those files for later analysis. So let's actually go through this demonstration here, and I'll just show you quickly starting a scan. So of course, I've got a very simple test set right here stored on the desktop, just a folder with several files. So I am inputting information here in the scan details. So of course, this can all be customized as you run the scan, depending on the specifics of your case. So you can include things like the investigator, the organization that is running the scan, and then any case specifics, case numbers, things like that. And then all of that will be included in the report that is generated by Stego Hunt at the conclusion of the scan. These are some additional scan configurations that can be used to turn on or off detection for specific file types. So that can be customized at the start of the scan. And so once the scan starts, you can see we've got very quick processing here as we go through. I'm going to skip a little bit here to the end, and then we can actually see the final result where we processed 67 files, 28 megabytes, and then we did full extraction of some archive files as well, and processed the multimedia files that were contained within those archives. So that's a quick demo of Stego Hunt MP, of starting a scan there. Very quickly, Gargoyle MP, The GUI you can see is very similar across the two. So we try to make good continuity between the two applications. So if a customer, is a Gargoyle customer or Stego and they would like to utilize the other platform, then they could do so easily without requiring a significant amount of, training or relearning a new tool. They should see that it's very familiar. So again, starting a scan basically looks exactly the same on the main GUI. There are a couple different options, of course, in Gargoyle MP versus Stego Hunt, because we're not looking at data embedded within multimedia, specifically in Gargoyle. We're looking for malware and potentially unwanted programs. So here we have the option to select either a factory dataset scan, factory or supplementals, which is the most complete scan that includes supplemental hashes from some of the most recent malware campaigns and those malicious files. And then also a custom dataset scan, as Amanda mentioned previously, where you could actually create a custom dataset of known files that you would like to look for, on a recurring basis, whether it's case by case or things like that. And then be able to detect the presence of those files as well, not just the files that are included within the Whetstone malware data set for Gargoyle MP that is distributed every month. Some scan option selections. Again, these look very similar to what you had in Stego Hunt MP, except this one also includes creating a hash file rather than specifically a case directory where we're capturing those media files. Here we're creating a hash file that can be used to rescan later. And this will just have a listing of all of the files and directories and the hashes and the file paths that are encountered during the scan as it progresses. So again, investigation information can be included here. And this can all be customized in the application preferences as well to include things like corporate logos, for example, in the report files. So here you can select, the types of program categories that you would like to use from the malware repository. As Amanda mentioned previously, there are about 25 different categories that you can choose from. And then you can customize this to suit your needs. And then, of course, that processed very quickly. We saw 375 megabytes scanned in about 10 seconds here. And so the number of hits are reported there. And then both of the applications have buttons to quickly view the reports in different formats, whether it's a CSV report, which of course can be used to be ingested by other applications to parse those and do some sort of custom action based on the detections. There is an HTML report, which is the most interactive report for the investigator to process the data and take a look at the findings. And then there is a PDF report that has a little bit different format, but is intended to have a portable document that could be used in something like a court of law and be used as evidence there as a PDF. So we can actually view these reports here. So let's take a look at this slide here. This is the HTML report for Stego Hunt MP. So up at the top, you can see things like this actual bar up at the top where you have quick navigation to the types of hits that were detected. So for example, BMP, GIF, JPEG, and so on, as well as the categories of programs that were detected. So in this case, there were no steganography programs identified, but there were some encryption programs, which are included in the Stego Hunt MP data set. So you can actually see those as well and quickly jump into them. You've also got overview of the information and the scan that was performed, including timestamps, which of course are critical for processing your data, the number of bytes that were scanned, and then the case specifics that were included when the scan was started. The operating system that the scan was run on, the system name of the scanning device, and then the processor that was used as well. And so you can actually scroll through here. You can see the options that were selected, the scan targets. So, of course, if you have an image file, You can see that as well. Some information specific to the program or the file types that were identified and how the distribution of suspicious and warning detections can be classified based on file type. And then you can see here the encryption program that was identified was NordLocker. Specific to NordLocker, you can see the file name that was detected, the original file name that was there, and then some specifics like MD5, and you can copy that MD5 and pivot over to something like VirusTotal if you're doing more of a threat hunting type of investigation. Here you can see BMPs that were detected with thumbnails. You can see more information about detections as we progress through here very quickly. And then finally, one other thing I want to point out is this directory hotspots feature. So this is useful where we're actually displaying directories specific within, the original image file, for example, that contained the most hits. So in this example, the threshold is 5 or more hits, and we see, directories that had 5 or more hits. And so you can really hone in on ones that really contained the majority of your hits, and then pivot and take a look at that directory and see, if that might be of higher interest to you in your forensic investigation. So you can see here all of the different directories that had hits associated with it. So that is the StegoHunt MP HTML file. Very quickly, I did want to show you the PDF here because it is a little bit different. As I mentioned, some of the pictures and things like that for the scan options aren't included in the PDF report just because it's important to just have a clean report file that can be used as evidence. But all of the critical information is, of course, stored within the PDF as well, including thumbnails that can be used in court. And then finally, very quickly, because the gargoyle reports look very similar to the Stego reports, again, everything is designed to be familiar to users across multiple tools. We do have the different program categories, again, up at the top. The same scan information specifics are presented there, the target of the system, detection results. So here we're looking at different program categories. And then, of course, you can expand those out and take a look at those as well. And you've got the same directory hotspots feature within the gargoyle scan report as well in HTML. So with that, I do want to take any questions that there may be. There is one question: can we detect APTs using these solutions? Yes. Now there are, of course, with the caveat that it is an APT that has signatures that are present. There are no 0-day detections with something like this because, again, this is not specific to gargoyle. This is not a malware detection utility that would be used as an antivirus, again, to detect and maybe stop that in real time, like running on a live system. But APTs that would be part of a larger malware campaign, for example, would absolutely be detected in something like a gargoyle NP scan. So that was the only question I see in the Q&A right now. If you do have any other Q&A or any other questions, please put them in the Q&A box and I'll be happy to answer those. Or if we don't get to your question, then we will reach out via email and make sure that we can get those questions answered. But I do want to thank you in the meantime, in case we do have some other questions, I do want to make sure that we have time to say thank you very much for joining today and being a part of this webinar. We do hope it was beneficial to you. If you'd like to reach out, there is some contact information here on your screen. That is the best way to reach out for more information, whether it's on the product or, of course, to reach out to Scientific Analytical Tools as well. So I don't see any other questions in the Q&A. So if there are no other questions, we'll go ahead and wrap up the webinar. Again, thank you all for joining and have a great day.